Welcome back. Today we're going to cover loops and we'll look at our first introduction to loops, which is the while loop. If you're following along in the book, Big Java Late Objects, you'll see that we are at chapter 4 and we'll start off with section 4.1 of that book. So there are many examples of where we could use loops in real life. One of those would be just calculating compound interest, and we'll look at that as an example. But there are many others. Simulations, event-driven programs. We'll see examples of these as we go through. And at this point in time, the world has been grappling with something called COVID-19. And so there are needs to model this and try to understand better how it's affecting people and how it could affect people so that we know how to proceed. So for every one person who contracts a virus, there are assumptions put in place as to how many other people it could spread to. For instance, if for every active contagious case that was out there, it spread to 2 people, we could maybe model it as follows. So if one person is contagious and we know that it spreads to 2 people, then the new cases that would result out of that one person would be 2 new cases, bringing the total number of cases to 3. Now those 2 active cases can spread again, and they would spread to 4 new people, causing the total to increase to 7, and so on and so forth. And so right now, people are modeling how this works, and this is a continuous loop that every time just keeps building. And so we can use loops to model something of this nature. Another simple example of what that could look like is interest growth on a savings account. So if you put $1,000 into a bank, at the end of year 1, you would gain interest on that account. And if you're getting 5% interest, that would be $50. And so your new balance would be $1,050, even without touching that account again. At the end of year 2, you now had $1,050 in your account. And so the interest is earned on this larger number. And so the second year, you would have earned $52.50, bringing your total in the account to $1,102.50, and so on and so forth. And so we can model this by using loops. This is an example of something that repeats and repeats over time. So you could just go through a certain number of years and figure out what you'd have, or you could take a different approach and you could say, I want to put $1,000 in and I know that my account will earn 5%. How long will it take for me to turn my $1,000 into $2,000 based on that interest growth alone? So we'd want to think about the steps to calculate that. And that's how we always start, is just thinking about the algorithm that we'd want to follow. So we'd start with a year value of 0 and a balance of 1,000. And then we're going to repeat the following steps while the balance is less than $2,000. We're going to add 1 to the year. We're going to compute the interest, which is the balance times the interest rate. We're going to add that interest to our balance, and that's the new balance for that year. And we're going to keep doing this until the balance reaches 2,000. At the end, we're going to keep track of that year number, and that final year value is our answer. So that would tell us how long it will take to earn enough interest to have a balance of $2,000. So what's happening? If we look at the flow chart of what takes place for this to happen, we come in and we say, while the balance is less than $2,000, so keep doing this while this statement is true. If the balance is less than $2,000, we are going to increment the year, add interest to the balance, and then proceed. Do this as many times as necessary until this condition becomes false. And so if you look at this structure, you'll see that there is a loop in our flowchart. And this is why the structure is called a loop. This is a while loop. We're going to do the following statements in blue while this condition, balance less than $2,000, is true. As soon as it's not, we're going to break out of this loop and proceed with the code that follows. So what does this look like in terms of syntax in Java? One example of a count-controlled loop, and we'll see examples of others, is that we have a counter. And so in this case, this counter is literally called counter. It needn't be, but it's initialized outside of the loop. And then we have a condition that's checked. And in this case, we're checking that a counter is less than some target. If this condition never becomes false, so if it's always true, for instance, if I change this to read counter greater than or equal to 0, then an infinite loop can occur. So we have to be very careful about what our condition is set to. Somewhere within that while loop, the counter should be updated, because if the counter never changes, there's no reason that we would ever leave this loop. That's an example of a count-controlled loop, a while loop that is controlled by some counter. In this simple example, we see that we initialize a counter before we enter the loop. Set, in this example, counter equal to 1. Then we do a condition check while counter less than or equal to 10. We check the counter against something and update the counter within the loop. That is a basic example of a count-controlled loop structure. But there's another type of structure, which is an event-controlled loop structure. And that's an example where when we wanted to check if the balance in our savings account had grown to $2,000, that's an example of waiting until something happens. So continuing to let it grow until something changes. And so in this example, we've got balance set to some initial balance, and we initialize that loop variable, and then we check the loop variable against some target and update different details within the loop itself. So here's an example of a while loop where we first set an integer variable I equal to 0, and then we initialize an integer variable total to 0, and we continue to do the following while the total is less than 10. We increment I, we set total to total plus I, and we print out each. So you see the first time we enter that loop, with both I and total are 0. 0 is less than 10, and so we proceed. We increment I by 1, bringing I to 1. We add 1 to total, bringing total to 1, and we output both, 1, 1. So you'll see in that output, the first column will be whatever is held in I, the second will be whatever is held in total, the value held in total. So we come back to the start of the loop with total set to 1. 1 is less than 10, and so that condition is true, and we enter the loop. We increment I becomes 2. We add that to our previous total, bringing total to 3. 3, we output both, printing that line to 3, and we return back into the loop. 3 is less than 10, so we increment I, bringing I to 3. We add that new value to our previous total. 3 plus 3 is 6, so our total is 6, and we output both, printing out the line 3 space 6. So total is now 6, which is less than 10. So when we return to the start of the loop, that condition evaluates to true. So we increment, we add that to the total, bringing total to 10 and I to 4, printing that 4, 10, and then returning to the start of the loop. This time total is 10, and 10 is not less than 10, it's equal to 10. And so that condition, it evaluates to false, and we leave the loop. And so as a summary of this, when the total reaches 10, the loop condition is false and the loop ends. If we look at this example, here is an interesting situation. We start off with I equal to 0, total equal to 10, but the condition that we're checking is while total greater than or equal to 10. This will have no output because when we first arrive at this while loop, total is equal to 0. 0 is not greater than or equal to 10, so it immediately evaluates to false. And none of the statements in that loop structure will be executed. And so that while loop is the condition returns false and we exit. There's no output. And this was probably meant to stop when we received at least 10. However, the condition controls when the loop is executed, not when it ends. And so if you find that you're not executing the loop as expected, you might check that you're actually checking the condition appropriately. You're setting the condition such that it controls when the loop is executed, not when it ends. A third example of that while loop would be one where we still initialize I to 0, total to 0. This time we check while total is less than 0. Again, there's no output because total is not negative, it's equal to 0. And so the statement is false when the condition is first checked and the loop is never executed. Here's a third example. This time, at least we're assured of some output. In fact, we're assured of a lot of output. In this case, we see I is set to 0, total to 0. But this time we can see that there is likely a typo. There's a logic error. And we have I incremented and total is set to total minus I. Now, maybe that's what they expected, but this certainly doesn't work with our condition because what that does is it takes total, which started at 0, and brings it negative. I keeps increasing and total keeps decreasing. So total will start it at 0 and it will always be less than 10. And so that condition will always be true and there's no way to exit the loop. The total will never reach 10. And this is called an infinite loop. It's an example of something that we try to avoid. So here's another interesting example that maybe looks okay at the outset. We set I to 0, total to 0, and the condition evaluates to true. Total is greater than or equal to 0. The problem you'll see in a moment. We increment I, we add I to the total, and both keep growing, right? It grows just as in example 1. 1, 1, 2, 3, 3, 6, 4, 10. And we note that we're not printing anything out. So we have no way to know how they're growing, but we know that they are by reading the code. The problem is, as they keep growing, total is always increasing, and so it's always staying greater than or equal to 0. That condition is always true, and it always will be, which means you've entered an infinite loop, and you're never going to get to that system.out.println. There's no output. The print function is outside of the loop, and so you never have any output, and you're stuck in this infinite loop. The total is always at least 0, and the loop runs forever. So there's some common errors. The first is an incorrect test condition. These are things to be aware of. The loop body will only execute if the test condition is true. And so if we look at the two examples, while the balance is greater than or equal to the target and while balance is less than target, they both involve the same two variables. But one is checking that the balance has met or exceeded the target. The other is checking that the balance is less than the target. If the balance is initialized as less than the target and should grow until it reaches the target, which version would you wish to execute? What we want to check is the bottom example. We wanted to check that the condition is met. We stay in this loop as long as the condition is met. And so the top version demonstrates the example of when we'd want to leave the loop. But what we need is a condition that checks when we should remain in the loop. Another common error is an infinite loop, an accidental infinite loop. The loop body will execute until the test condition becomes false. What if you forget to update the test variable? So balance is the test variable and the target doesn't change. If you don't update it, as we see in the bottom example, if we forget this very, very important step, balance equals bal plus interest, you will loop forever or until you stop the program. Another common error is off by 1. A counter variable is often used in the test condition. Your counter can start at 0 or 1, but programmers often start a counter at 0. The reason for that is simple. If you want to paint all fingers on one hand, then if you start at 0, you use strictly less than, and less than is just one less character to type. If you start at 1 and let finger run from 1, 2, 3, 4, 5, which seems logical, you have to use less than or equal to. It doesn't matter which you choose to do. It's common to start from 0 and use strictly less than. But if you don't, just make sure that you remember to use less than or equal. It's up to you.
Wait, what are we waiting for? Can't you just loop us into the next bit? I'm ready for it.
So I'm guessing you've figured out what comes next. Next time, we'll take a look at for loops.
Thanks for watching.
See you next time. All images are thanks to Wikipedia Commons.